And here's why. Okay, and yeah, leave answers is either proper or improper fractions. No mixed numbers because we hate those, and I hope someday you hate them too. So when we have these, if I had 2/5 of 3/8, what this means, and this is all we're really going to do, is multiply the numerators. So 2 times 3 is 6, and then 5 times 8 is 40. Now this one will require some simplification. We can divide both these by 2, and 6 divided by 2 is 3, 40 divided by 2 is 20. But that's just one method. This is not a good example to show, but for the other method. So again, just straight across, 5 times 1 is 5, and 6 times 3 is 18. That can be simplified, so that is our answer there. All right, now this problem is a good example for what we're going to call cross simplification. So before we do that though, I just want to acknowledge that we have this negative, so the answer will be negative, okay? And it should come out as a fraction. Whether it does or not doesn't matter yet. Now this one takes a little intuition, so whether you use this strategy or not is up to you. But I can see right off the bat that 5 and 10 is a multiple of 5 here, or they're divisible by the same number, however you want to look at that. So if I divided 5 by 5, I would get 1, and 10 divided by 5 is 2. So I simplified those two numbers. I'm just making them smaller to make them hopefully a little bit easier to work with. Well, 9 and 6 also are divisible by the same number, right? We can divide this by 3 and the 6 by 3. Simplifying these two gives us a 3 and a 2. Now I'm going to ignore those numbers, so really what we have is 1/2 times 3/2, and yeah, we can say that's negative. But see how that simplifies it right away for us? Again, it's not required that you do this because it does take a little experience to really get this down. But 1 times 3 is 3, and 2 times 2 is 4. So the answer to this one, negative 3/4. All right, this one will use straight multiplication. Now again, if you want to simplify it, that's fine. The nice thing about this is that I've got two negatives, which means I'm going to take the opposite of a negative, making that positive. And from there, I can ignore the negatives. So I can just do straight multiplication. 9 times 2 is 18. Again, this would be good on a calculator. 18 times 5, 90. And then 10 times 15 is 150 times 3, 450. All right, I can see right here, since both of them end in 0, some people would say just cross these out. I'm going to say that we're going to divide by 10 just to keep things consistent right now. 90 divided by 10 is 9, and 450 divided by 10 is 45. Now both of these are divisible by 3, but in addition to that, both of them are divisible by 9, which would simplify this right away, 1/5. Now just looking back at this, right, we could have simplified the 9 and 3, that would give us 3 and 1. 10 and 2 would be 5 and 1. And 5 and 5, just 1 and 1. So 3 over 15, I mean, if you really wanted to, you could simplify right there and make that 1/5. Again, we don't have to like that way, all right. All right, so we did fraction multiplication. As it turns out, negative 10 is a fraction. What's its denominator? 1. Well, 1's a pretty easy number to multiply. And we got the two negatives, which will make them positive. Which is nice, again, because we don't have to worry about that. So, fraction multiplication, 10 times 4 is 40. And 1 times 15 is 15. So to simplify this, looks like both of these are divisible by 5. And that would give us 8/3. That's as far as we can take that one. And I believe it did want an improper fraction, so that's good. All right, number 8 right here. Now we do have that negative in front, so again we can do that. But right here, what I'm going to do is by multiplying these two, I can rearrange this, okay, because ultimately we just have one full fraction. It's just we got multiplication between these. Multiplication allows us to move these around, the commutative property of multiplication. So what I can do then is take 2 times 3, and then I can move the x's closer together, and then the y's like this. Now again, this is not necessary that you do this. Some people just like to find the x's and the numbers and y's, but whatever. In the denominator, again, I will move the numbers close together. There's only the x squared, and then I've got the 2 y's. Well, anything divided by itself is 1, so there's the 3's. Those cancel. I got 2 of these x squareds, and I've got these 2 y's as well. So what are we left with? I got negative 2x over 4. And we can simplify the 2 and the 4. Divide the 2 by 2 and the 4 by 2. And this is negative. You can put 1x if you want. Or you can just make it an x. That's not going to matter to me. So let's just show it. What the heck. That's good. So let's just do straight multiplication on this one, right? And again, we got the 2 negatives, which is just going to cancel those out. So if I multiply this, 15 times 5 is, that's not 45, 75. And then I've got times p squared times q. Okay, we can multiply letters together even if they're different. That's not considered combining unlike terms because it's multiplication. And then the denominator, 10 times 3 is 30, times the, I'm going to rearrange these p and the q. Now with these numbers, 75 and 30, both of these should be divisible by 5 at least. And some of you guys know that they're divisible by 15, but whatever. So that gives me 15, excuse me, over 30 divided by 5 is 6. Now I'm going to expand the exponent there, so that's p times p, and right there we can see that the q's will cancel out. Now whether you do this all in one step or separate steps is not going to matter as long as we cancel out the right things at certain points. And then I've got the p there on the bottom. So right here those p's will cancel out, and 15 and 6, both of those are divisible by 3 again. So 15 divided by 3 is 5. Over 6 divided by 3 is 2. And we just got that p. That's it. So let's use multiplication on this. 15 times 7, 70, 105. And we do have the a squared there. 28 times 10 is 280. So the a squared, there's really nothing we can do with that. But the 105 and the 280, I'm seeing both these are divisible by 5 at least. So that gives me 21a squared over 58. 58 and 21, they're not divisible by, no, it should be 56. I'm sorry, see, that's why we should have a calculator on that. 3, yeah, that should be 56. Now this, we can divide these by something. 21 is divisible by 7, and 56 also divisible by 7. 21 divided by 7 is 3, 56 divided by 7 is 8, and we got that a squared. 3 and 8 can't be simplified any further. So there we go. All right, so this one is cubed. So let's expand this. We got negative 3/4, that's 1, times negative 3/4. That's 2 times negative 3/4, that's 3. Now 2 of these negatives will cancel out, that's nice. But let's do the multiplication. 3 times 3 is 9, times 3 is 27. And we have that one negative left over, so it should be negative. And then we got 4 times 4 is 16, times 4 is 64. This, as it turns out, can't be simplified. 27 has no common factors with 64. It's done. Let's go ahead and expand this again. 2/3 times 2/3, and you don't even really need to use the parentheses on this, especially with positive fractions. But when we do this, 2 times 2 is 4, 3 times 3 is 9, done. Alright, so when they ask for the area of a triangle, here's the thing for any triangle really. Is a triangle, if I took this thing and just kind of flipped it upside down like this, it becomes a parallelogram, which is essentially a rectangle. So, I mean, we would find the length, and then we'd find, if we cut that piece off, we'd put it right here, and now you do have a rectangle right there. So if we found the height of that triangle, it would be kind of considered the width of that rectangle. The problem is that it's just been cut in. It's been cut in half. So if we looked at a rectangle specifically, and we cut it in half, we got 2 triangles. But a triangle is only half of that, so if we took the length times the width and just cut it in half, then we have the area. Now we don't call that length and width anymore. For a triangle,
Base and height.
there you go. Yep,
Okay.
base and height. Now some people write this differently, so whichever way works for you better. Base times height over 2. Now the problem with this second one is we haven't really gone over division like this yet, but we could also say, I'm sorry, like division of fractions, but we could say that we would just divide that by 2. So.